Ya, per favore.
Hello. Good morning, good afternoon, wherever you're joining us. It's really great to see everyone. And Danilo, how are you? Good to see you today.
Ciao Rosina, very good. I'm good, and thanks a lot to invite me. It's fantastic to be together at this event of the talks.
Yes. So before we start today, we do our usual public announcements, what is coming next in the foundation. So especially Danilo, you can share with us what we have planned May 27 and 28, right? About the third Gen AI Forum. So Danilo, you are the best that can give a good introduction.
Yeah, thanks a lot, Rosina. Me and Professor Ajar Musanif are organizing a very breathtaking events on May 27 and 28 online with the full support of AGI Foundation. Essentially, we are going to have the third forum on the journey to impact about Gen AI at the edge. So we will have top speakers from the industry and from top universities. And I remember Intel, NXP, Qualcomm, Wipro, MIT, ST, and certainly I forget others, but really it's huge, and people are very expert, are top leaders, and we will have a great event in the sense that people is really eager to witness that generative AI and agentic AI is going to impact what we are doing at the edge right now, not in 10 years. And that's going to be a great event. So please register as soon as possible and be with us. It will start, if I remember, Rosina, 5 p.m.
It's 8 a.m. Pacific, which is for you 4 in the afternoon, European time, right? If I calculate, no, it is 5 p.m. actually. Yes, you're right.
Yeah,
5 p.m. because it's 9 hours difference, right?
Yeah, and it's going to be a great event. And really, the agenda will be available very soon, but the speaker list is finalized, and we are going to communicate that with the AGI Foundation very, very soon. So it's you cannot miss it. You have to be with us, and
I agree with you, Danilo, and thank you so much for your work. And here is the link just to our website. I invite everyone, just click on our website, and there you will find the link directly to the event that Danilo mentioned. It is May 27 and 28. It's a virtual live stream event. And it's a free virtual webinar, so to say. So please don't miss out. And so just register. Don't think about it twice. And then the other thing that we have also for you, Danilo, because it's back in your hometown, right? We will be July 2nd to 4th, the Edge AI Foundation. We will be there with our other yearly annual event, and we will be again in Milan. And it will be one of our epic and even better than what we had in Austin. So everyone has been working really hard. So we are looking forward to see you all in Milan, right, Danilo? You will be there as well.
Yeah, thanks a lot, Rosina. Really, I am very, very happy and grateful to the AGI Foundation and all the partners that support the foundation, because for the second year, we are going to have this amazing and very rich of content forum in Milan. And I wish to meet you all, and and a lot of people there, because the agenda and the topics about AI at the edge, including workshops, including tutorials, posters, speeches, live demos from many companies. It's an event no one can miss it if really want to stay up to date at the edge. So we are going to have these two events very close, 1 month far each other, and the third forum and the EMEA forum in presence in Milan, beginning of July, and I mean, I cannot imagine a more exciting period ahead of us.
Yes, definitely. So we are all looking forward to see you there in person. Danilo and myself, we will be there, and it will be really great to meet all of you. We have those amazing networking events. Then we also, as Danilo already mentioned, there are many workshops, different presentations, posters. So it is really the event where to be, everything related to Edge AI. So the website is there, so just click there and you will find the link for both of the events we mentioned today. And then another note for me, as you can see, I have my Edge AI Foundation t-shirt, and also I have here this, which is our new, how it is for, the good thing is now, especially that later on we will have a professor and some students, all that, there is also the link where you can order it, and that is to support our scholarship fund, because we really want to help and always include our students. So I invite everyone, if you want to get one of those t-shirts, or you have seen Pete always with his Edge AI Foundation hoodie, so that supports our scholarship fund. So invite you.
We need to know and be aware that research start not only from industry but often from university. So we need to be very grateful and supportive of all the efforts that university put to improve the knowledge and sharing on this important topic, which is Edge AI.
Yes, I agree with you, Danilo. And without further ado, I welcome today's guest. So I'll say hello to Vadiraja.
Hello.
Hello.
He
Hello
is
all.
professor from the PES University from Bangalore. And then we also have Bavitha and Prajwal. They're joining us today. And so they will be talking about energy efficient indoor asset tracking for Industry 4.0. So you're welcome. And thank you very much for being here today.
Thank
And
you.
I will leave it to you, Vadiraja. I will bring up your slides, and then Danilo and myself will go in the background, and you will be the one in charge for today's
Thank you.
presentation. So take the floor away, Vadiraja.
Yes.
Have you.
So hello all. Good morning, good afternoon, wherever you are, depending. So as Rosina mentioned, thank you, Rosina and Danilo. Thanks AGI Foundation for providing us with this opportunity to present the work done at the PES University in Bangalore here. So along with me, I have Bavitha and Prajwal, who are my final year BTech students of computer science and engineering. So the work that we're going to present today is part of our capstone project. So the title is Energy Efficient Indoor Asset Tracking for Industry 4.0. So as we all know, Industry 4.0 has its own challenge. So it all started around a year ago when I was giving a talk in HAL MA here in Bangalore, and then there was a faculty who also works as part of the Forge and Foundry division of HAL here in Bangalore. So they have this problem of people who work on the floor who forget the dies in the manufacturing facility here and there, and they find it really difficult to track them down. So this particular problem is not unique to HAL or any other. It's common in majority of the mass production industry. So we were just brainstorming on what can be done. Asset tracking is one good thing which Industry 4.0 actually brings up. So we searched as to what all can be done. At the same time, students approached me for an idea for capstone, so I presented to them. So they came up after a wonderful literature survey that we can go with BLE and Wi-Fi for real-time tracking. Now, there are multiple ways of doing it. the classical way of doing it is to go with fingerprinting. So you have the beacons in the manufacturing facility in the corner, in some of the corners. Then you take the RSSI value, you take the readings, and then you train a model, or you just feed the thing, and then you get some kind of feedback. But then the other part of it is using Edge AI to come up with some really wonderful algorithms for asset tracking on these resource constrained devices. So naturally, when we are trying to track a device or an asset, the tracker should not be a very huge one. It should be a very tiny device which can be pasted or which can be placed on the asset that we are trying to track. So we thought of going with Arduino Nano 33 BLE Sense, like how everybody starts off their TinyML journey, and also use Raspberry Pi Pico W, which is equally tiny in nature and which can run on battery for a very long time. So the aim was to create a 3D model of the place where you want to track the asset, and then visualize also in real time where the asset is, how it is moving. And what we have tried to do is to use these two different microcontrollers. So as I told you, we had two different approaches. One is the fingerprinting based one, and the other one is the TinyML RSSI classifier. So both are low power devices, and which can, with particular performance tweaks, can run for a very long time on battery. So that's one of the major things, because the beacon can be running on the raw power, but the tag that sits on the asset should run for a very long time. So we don't have time to keep shifting the battery pack every now and then. So that's where the TinyML and the low power Edge AI comes into picture. So, so this is the testbed setup or the way we actually went ahead. So this is the floor plan of our Center of IoT here in PES University. So we use that as the initial test scenario. So wherever you see those four cross marks, that's where the beacons were kept. And we use the Raspberry Pi Pico W as the beacon. So it advertises both the Wi-Fi and the BLE signals, and it was charged with a 3.7 volt and a 600 mAh drone battery. So this is sufficient for it to run for a very long time. And all the other architectural part, I think I'll allow my students to take it up. I think the minimum size of the asset that we planned was keeping in mind the tiny board that we are using, the Arduino BLE Nano and the Raspberry Pi Pico W. So it should be slightly larger than 6 centimeter by 3 centimeter by 3 centimeter. So finally, we could really have a headset ready 3D visualization of the asset in real time. So how we achieved, I'll allow Bavitha and Prajwal to explain it to you guys. Over to Prajwal, Bavitha and Prajwal.
So coming to the system architecture of the two microcontrollers, which are Raspberry Pi Pico W and the Arduino Nano 33 BLE Sense. The beacon, which is the Raspberry Pi Pico W, which transmits Wi-Fi and BLE signals, is common in both the architectures. In the Raspberry Pi Pico W architecture, the tag which is placed on the asset receives Wi-Fi signals, and the access points are identified using the IP address. So the RSSI values and their respective IP address along with the bay labels are stored in the form of offline data, that is the offline phase, and then the real-time online data compares with the offline data, and the asset's estimated location is sent to the Firebase. And in the Arduino Nano 33 BLE Sense system architecture, the tag receives the BLE signals, and then over here the access points are identified by their MAC address, and the RSSI values. Both of these are stored in a CSV file. So we made a machine learning model which is trained to classify the RSSI values into specific bay labels. So the real-time data is compared to the model, and the asset's location is estimated to the Firebase, is sent to the Firebase. Yeah. So coming to the TinyML pipeline, which we used for BLE, the first step in this workflow was data collection. So we collected the RSSI values from the 4 beacons along with the bay labels and put it into a CSV file. And then this CSV file was uploaded. Next step is the pre-processing and splitting, where the data is split into training, validation, and the test sets. And the architecture which we used is the simple feed-forward neural network, which is a type of dense neural network. And the reason we chose this network is because the feed-forward neural network is best used in tasks where classification is used. And in our project, the thing is classification, and the feed-forward neural network is used to rectify the problems where the input features are independent of each other. So this is best suited for our system as the RSSI values from different advertisers have separate measurements. And the layers which we used, so the input layer had 4 neurons, which represent the 4 RSSI values coming from the 4 beacons. It consists of 2 hidden layers having 16 neurons each, and the output layer comprised of 9 neurons, which represent the specific bay labels. Like we had 9 bays, so 9 neurons. And then we converted the model from TF-Lite to .h file, because that is compatible in Arduino IDE, and this was used to predict the bay in real time.
So now coming to the part where we have incorporated power consumption methods. So the main agenda of using power consumption is to increase the battery life of the beacons. So that's where the term energy efficient comes into play. So some of the optimization techniques which we have used on the beacons that are placed in the 4 corners are by increasing the BLE advertising interval. So what this does is the rate at which the BLE signals are delivered is increased. So initially the condition was at every 1 second the packets are going to be released. So we have changed 1 second to 2 seconds. And the next method is by increasing the Wi-Fi sleep period. So this part comes into play when in the Wi-Fi. So in Wi-Fi signals, what happens? In the initial condition, it was 3 minutes. So an optimized condition is by increasing the time in which the Wi-Fi signals are sent. So the next point is we are going to be disabling unused hardware. So suppose in the Pico W there's an LED, so we do not make it glow. So that saves on power. So and one more power consumption method is by introducing staggered wake up intervals. So wherein we have incorporated a 3-minute cycle, wherein for 1 minute the Pico W stays active, and then for the next 2 minutes the Pico W goes into sleep mode. So as you can see in this tabular table, so without any optimization, the Pico W lasted for about 5 hours, and on incorporating only the BLE advertising interval parameter, we got a runtime of 5.4 hours. And when Wi-Fi sleep period, only Wi-Fi sleep period parameter was optimized, we got a runtime of 5.6 hours. And on introducing a staggered sleep cycle of 3 hours of a 3-minute cycle, we were able to get a runtime of 5.8 hours. And hardware shut off, wherein we killed all the LEDs which were glowing, we got a runtime of 5.2 hours. So on including all the optimization parameters, we were able to get a runtime of 7 hours. So we were able to make the Pico W last for an extra 2 hours. So this pie chart shows the percentage distribution of each of the parameters. So with the major one being staggered sleep cycle, which contributes to 35%. And the second comes the Wi-Fi sleep period. Optimizing this parameter contributes to 30%. And then comes the BLE advertising interval, wherein when we optimize it, we get a 20% contribution. And then finally is the hardware shutoff, which contributes to 15%. So these graphs are the accuracy versus each parameter. So in the first graph, as you can see, on the y-axis we have the accuracy, and on the x-axis we have the BLE advertising interval in seconds. So in the initial condition, when it was set to 1 second, so we got an accuracy of about 70%. And optimizing it, that is by increasing the parameter from 1 second to 2 seconds, we got an accuracy of 68%. So this is considered as the threshold. So beyond which we do not go, as the efficiency drops. So the accuracy drops by 70 to 68%, but our main motive was to increase the battery life. And coming to the Wi-Fi sleep, as you can see, initially it was set to 3 minutes. So we got an accuracy of 70% in the initial condition. Optimizing it to 5 minutes. So we got a slight decrease in the accuracy to 67%, which is considered as a threshold. So this is the third parameter, which is introducing the staggered sleep cycle. So without any of this parameter, we got an accuracy of 70%. So when introducing this parameter, so the accuracy dropped to 65%. So this is a 3-minute sleep cycle. So on an average, on including all the 3 parameters, we get around 67% accuracy, where there is a 3% drop in accuracy. But we, on including all these parameters, we were able to increase the life of the PicoW to an extra 2 hours. So this is the comparison between both the microcontrollers, which act as the receivers. That is, they are placed on the asset being tracked. So in PicoW, a battery life of 6 hours, and whereas the Nano 33 BLE sense, we got a battery life of 9 hours. So the RSSI accuracy, which tells how far the PicoW is from all the 4 beacons, so that is slightly less accurate when it comes to the PicoW as compared to the Nano 33 BLE sense. So some of the development tools that we used to code in PicoW was the Thorny IDE using the MicroPython module. And some of the development tools that we used for the Arduino Nano 33 BLE sense is the Arduino IDE. So when it comes to prediction of the bay, so in PicoW it is slightly slower and less reliable as compared to the Nano 33 BLE sense, as the prediction of the bay is quite fast and more accurate when it comes to Nano 33 BLE sense as compared to the Raspberry Pi PicoW. So finally coming to the result, so we were able to achieve an energy efficient IoT based solution to track the assets in real time using communication technologies like Wi-Fi and the Bluetooth Low Energy. So these technologies align with the Industry 4.0 standards. So by integrating the concept of collecting RSSI data, introducing machine learning models, and also creating a 3D visualization which tells where the asset is located in real time, aligns with the Industry 4.0 standards. So also by performing this study, we were able to compare the performance of both the Raspberry Pi PicoW and the Arduino Nano 33 BLE sense. And also by this study, we were able to conclude that there is a slight superior, the Nano 33 BLE sense offers a better accuracy as compared to the Raspberry Pi PicoW because of some of the capabilities like Edge, TinyML, and the ML capabilities are restricted on the board itself, so it need not be sent to any cloud server. So, so we were able to demonstrate a real-time indoor asset tracking system for this application. So this is a video which shows that is the asset being tracked, and this is the 3D model that we have developed, which is 3JS based. So as and when the asset moves from one bay to another, the location is updated. So before it was placed in bay 7, and now once the object is shifted to bay 9, the respective bay label gets highlighted in the 3D visualization as well. So now the asset is being displaced from bay 9 to to base 4. So once the asset is placed there, in a couple of few seconds, the base 4 gets reflected, highlighted in the 3D visualization as well. So this is the Arduino Nano 33B license, which works the same way as the Raspberry Pi PicoW. So as and when the set is displaced from one bay to another bay, so before it was in bay 7, now it is being displaced to bay 9. So after a couple of seconds, the particular bay is highlighted to tell where the object is without manually finding it. So this saves a lot of time and effort, and it makes it more convenient to track assets. So now it's again placed in bay 9. So the particular bay gets highlighted.
So the basic idea was to make sure that the asset, as I told you, there was a size to the asset. The assumption was that the asset is not more than, not tinier than 6 centimeter by 3 centimeter by 2 centimeter. So even if the asset is, even if in the 3D visualization we are able to locate it with an error of 1 meter or whatever, it's okay because the asset is quite larger. We can go there, see in the bare eyes, and then get it. So the idea was to reduce the energy consumption and not the accuracy in terms of the location as such. So because the asset itself is quite larger, but if you scale it, as in if the indoor the floor shop itself is quite big, then we need to have more beacons in place, and we need to get the RSSI values and train the model so that the location accuracy is achieved. One other thing that we did not mention is the space that you saw in the video was our lab here. You can see that we have placed the beacons in the 4 corners. So if you can see the I think you will be able to see the beacon here. I'll try to pause it in a place where I can see that. So in the 4 corners, I think we have placed it. So we have placed the beacons in 4 different corners, and we had taken the readings, and then we ran the TinyML model as explained by Bavitha and Prajwal. So this was the idea that we wanted to present. So you can see the beacon there in the corner. Right.
Thank you. There are many questions already. I would like to ask them if that is okay with you.
Yeah, please go ahead.
Just to bring them up. For example, we have the first question here from Samart. It says, how is the 3D model of CIoT lab generated based on this approach?
So this 3D model, we have developed it on our own using Blender. So then we using 3JS, we rendered it. So we have created this model on our own in using software like Blender. So then we have rendered it using 3JS. So wherein the data from the Firebase is fetched onto the 3D visualization. So as and when the data in the Firebase gets updated, the particular bay label fetches it from the Firebase, and then it is made to reflect the corresponding bay label in the 3D visualization.
Okay, thank you. That is great. Let me see. The next question I have here is from, I'll show that here. It's from Philip Marsolf. What trade-offs were considered when designing the NN, power, memory, footprint, accuracy, etc.?
Okay. So we decided on the simple feed-forward neural network as I said, it was best used for classification, and we came up with, like, first we used only one hidden layer. but that was not like, it was not giving proper results, and it was showing it was underfit. Then we tried with 2 layers that was showing the maximum accuracy. We went ahead and tried it with 3 layers, but putting 3 hidden layers made it a lot complex, and there was overfitting that was being seen. And the output, we used 9 neurons since we just have 9 bay labels, and the neurons 4 because we had 4 beacons placed in the room. So we used 4 neurons, each representing the RSSI values coming from each of the beacons.
So naturally, the choice of the hardware also played a very important role here, because we had to finally fit the model on a device like Arduino Nano 33 and also the Pico W.
Okay, thank you very much. Okay, let's see. The next question I have here, it says, this is coming from Gigi. Can you kindly talk more about the intelligent aspects of the AI and NML's input, learning weights, output? So if you would like to mention that too.
Okay. So as mentioned in the slide, so we had the 4 neurons which are considered as the input, as in the 4 different beacons which were there in 4 different corners, and then the 2 hidden layers which are as Bavitha told. We had 16 neurons, and then the output was the 9 neurons based on again the 9 different bays. So learning and weights, I think we'll have to go to the code aspect of it. We'll share those details offline.
Okay, thank you. Then the other question I have here is, what kind of use cases would this be applied to? That is from Siad Yusfi.
Yeah, so in all those places where you have to track these tiny devices, say for example, I have seen a French company which does this tool tracking within a manufacturing facility. So tools, there are cases where these tiny tools are there, which multiple teams within a manufacturing facility need it at the same time. So it's like Ola, Uber for tools. So you need to know where those tools are for that particular manufacturing process at that particular time. So you have a nice graphical user interface which gives you the real-time visibility of where that particular tool is at that point in time. If somebody has forgotten it in one of the corners of the manufacturing facility, you can go there and pick it up. And using all those data, you can run analytics as to which particular team is using it more, when which particular process needs that particular tool, and all that. So what we have shown is just the tracking part. Maybe the next step would be to do the analytics part of which particular bay is using this particular tool more, and where is it lying idle, and things like that. So that's where the application comes from. In fact, I started off with this talk with an example of that HAL Forge and Foundry use case, where the dies itself are forgotten in one of the corners of the manufacturing facility, and then they spend a lot of time manually looking for it, right? So in all those cases, we can use this.
Yeah, that's actually really good use cases. I don't know. I see Danilo here. Something you would like to add?
Yes, please, Rosina.
Yes,
First
you
of all,
use cases. So yes, you.
Yeah. First of all, thanks a lot for your very interesting work and presentation. I mean, the work is really useful and is well placed in the domain of low power and edge devices. I see you approach the problem from a classification perspective. I wonder if moving to a regression problem, for example, computing the direction of arrival, could be doable. I have also other questions, but if you allow me one by one.
Yeah, sure. So yeah, I think that can be tried out. I mean, as I told you, to predict where the tool can be used next, or even to track it in. So our assumption was that a particular tool, when picked up, would be used for some amount of time in a particular bay, and then as part of an inventory, we need to know where it is. So that's why we wanted classifier to be used, because we did not want a real-time visualization, as in the actual movement, like how you do fleet management. We did not want to go there. So we ultimately wanted to know where the asset is as of now within a closed door. So that's why we did not go for regression as such.
Thank you very much. In terms of power profiling, clearly the nano board is winning. I mean, the battery life or the extension is clearly visible. I wonder, in your experience, for a more profiling detail point of view, which are the components that definitely allow to save energy by using the nano approach?
So as mentioned by Prajwal, we have tried all these options of the advertising interval, the Wi-Fi sleep period. There are a lot of unused hardware on the board itself, like JTAG or the LEDs or some of those things which are unused pins. All those things can be removed just to make it deployment ready, and then make sure that it uses very less power. In fact, the approach that we took was, as of now, we are working on the beacon, which is static in one place. The other improvement that we are trying to plan next, the future scope, is to reduce the power consumption on the asset itself. So on the asset also, because it is battery driven, we want to try out what if we switch this, the asset becoming the beacon and the tag sits somewhere in the static location. So we want to try that also and see how the battery on the asset itself lasts long. We want to try that also.
Thank you. I will use another question that we have from the audience, and then I know Danilo, he has so many other questions, but I'll just share right now the other one from the audience. For example, we also had, for example, that is very interesting, from Ravi Bhushan. He's asking, what is the size of the indoor area you used for the test? And how can you scale up to a bigger area of a warehouse?
So the image that you see here, we tried it in 177 meter square area. So we are yet to test it as part of the scaling option. I think because this is a capstone project, there is always another team which is ready to work on this. We will surely try scaling it for a larger area and then see. So that again depends on the range of the BLE itself, which is not more than a few tens of the meters. So we are yet to scale and try with multiple devices, with multiple beacons and all that.
Okay, good. Thank you, Vadiraja. I have another question that is again from Gigi, and a lot of people wanted that we ask that question. It says, I am not clear about the TinyML use in this. It seems this level of asset tracking has been or can be done without ML. Can you kindly clarify and elaborate on the ML Edge AI aspects?
Yeah. So in our talk, we mentioned two different approaches to solve this problem. One was based on the fingerprinting. So based on the fingerprinting, you see the RSSI value and try to find out where it is. So that is one part of it, where we initially had the Wi-Fi as the beacon, and then turn on the Wi-Fi on the tag, and then look at the RSSI value from four different beacons, and then try to find out. So that didn't give us better results. That's where we shifted to the ML part. And why we need ML here is because we need possibly to change the locations. And then we are not sure whether we will be using the same floor every time. And we don't want to hardcode things, right? So depending on the performance tweaks and other things, we have to shift to different things. So that's why we went to ML or Edge AI rather than the fingerprinting way of doing it. And we refer to a lot of online literature survey also. Fingerprinting was already tried for such things. So that's why we thought of shifting to TinyML and run the logic on the device itself. I hope it answered this question.
Yeah, I'm sure it did. So thank you very much. Another one that I think is really interesting too, because they were asking if, for example, just let me click if I have it right now, because they were asking if it also works on, here, I'll show this question, is from Siad Yousefi. He's asking, do you know if this method can track metal assets, interference with objects? So I don't know if you can also answer that.
Yeah, so we are yet to try that. We are not sure. We are yet to try it on a metal object. We are yet to try that. We have not tried it yet.
Okay, good. And for example, there is another question from Antonio Fardioni. He's asking, did you consider using RFIDs?
Yeah, RFIDs are the classical ways of doing it. You need to scan it every time, so you need to be really very near to the scanner or whatever. So we did not want the asset to be getting scanned like that, right? So we wanted to try a different way, so that's why we went with BLE.
Okay, thank you. Yeah, there's so many more questions, but I don't want to keep Danilo out. So Danilo, if you want, I'll also let you ask questions. We really have so many questions from the audience. But yeah, Danilo, you can.
Yeah, thanks, Rosina. A couple of curiosities. In terms of resolutions, how far your method can go? I mean, how close the objects you want to track could be? Is there any physical limits that we're going to approach?
So that part we are yet to kind of complete the study on. But we started off with this project having the assumption that the asset is quite large, and then we need to only go to the precision of around 1.5 meter, 2 meter plus or minus, because that asset can be seen once I know the bay. I can go there, search or do a bit of pondering over there within the table and then search. But of course, as you mentioned, that precision is something which we are yet to try by reducing the size of the asset itself, and in the bay, in which corner of the bay can it actually identify. That part we are yet to kind of study. We are I think we should be able to get some kind of precision.
That's cool, fantastic. The second curiosity, Rosina, if you allow me, is more forward-looking. I mean, do you see a scenario or possibilities to overcome the usual procedure? You know, collect data, build the data set, and do the training of the tiny neural networks, and then put it in deployment phase. Would you envisage a scenario, devise a scenario more dynamic, where essentially you don't know how these things are placed, you learn dynamically, and then you apply the knowledge acquired, and maybe from time to time you re-update?
Correct. Yes, we should do that. We should be able to kind of have that flexibility of not train at all, but still we should be able to track the devices effects based on the RSSI value or whatever. Yeah, we should be able to do that. We'll try it. Yeah, sure. Thanks for the input. Yeah.
That would be fantastic. You know, this topic of dynamic learning, on-device learning is another topic which is of interest in the AGI Foundation, with some challenges, obviously, but yeah, so let us to be up to date with your work if you plan to do anything in this direction.
Sure, sir. We'll keep you posted. Yes, sure.
Yes, I am sure Vadiraja will definitely let us know. So just one quick question, Vadiraja. I don't know if you have more slides or you were finished with the presentation.
No, we don't have any other slides. We are
Okay,
open for the
that's good,
questions.
because then we keep asking questions. I was just not sure because I didn't want it to, and then you're like, oh, I have more slides.
No. We are done with the. We just wanted to keep it precise and open
Okay.
it for more
Yeah,
questions.
that's perfect. For example, another question. I don't know, Danilo, if you maybe have one of your favorite, you can also let me know. But I know you have some problems with the reading, so I will just bring
And
up.
yeah. If I may, there is a curiosity. I mean, one of the people of the attendees commented that I don't know if you already read it, Rosina, that maybe simultaneous localization and mapping could be an alternative. How would you comment this opinion, this approach?
Sorry, which of the comment you were referring to, sir?
There is a comment from Samarth NN. Would SLAM-based approach be better for this?
Here.
Oh, SLAM. I don't know. I mean, SLAM is mostly used in the robotics to track the movement of the asset. Used with the point cloud and the radar-based stuff, the lidar-based stuff. So I don't think so. That would help us in this particular use case.
And I think,
I mean, we did not keep an eye on the comments. Sorry if that. There is one question by Joe, I think. Where is the ML model located? Is it on Pi?
No,
It's on the Arduino Nano BLE, not on the Pi. Yeah. Yeah. More questions. Rosina, I think you are muted.
Sorry, yeah. Li Yuan Wang, he's asking, can you kindly talk about the considerations of hidden layers?
Yeah.
Yeah, I think I had already answered this question about the hidden layers. We decided to use two hidden layers since it was best related to the accuracy and precision. When we used first one hidden layer initially, it was not giving that accurate values and the RSSI values, and even the bay was not being located exactly. Then, like with two, it was giving proper precision. With one hidden layer, it was underfit, and using three hidden layers would make it very complex and overfit. That's the reason we stuck to using two hidden layers, having 16 neurons each.
Okay, thank you, Bavitha. Let me see other questions that we have. The question from Michael Dew, I think, has not been answered yet, if I'm not mistaken. He says, need to learn more about the improvement rate is only 3 to 5%. Is that enough to say that BLE made a significant improvement? How to get the 20% more improvement?
Yeah, so one of the answers would be to collect more data, about the RSSI, run multiple iterations, and improve the model. And also on the, as I told you, we wanted to shift this beacon and tag approach. We want to try that also. I think if we change that approach of static tags and mobile beacons, I think that also would give us more improvement. And also the battery optimization techniques, we want to explore more on what all can be done as uh, discussed earlier. Yeah.
And also one way would be to increase the number of beacons as well. So if you're going to place more number of beacons, so the asset when it is near the beacon, so it gives a much better accuracy. So increasing the number of beacons as well improves the accuracy of the system.
Okay.
That's one thing that can be tried. Yeah.
Yeah, thanks, Prajwal, for that. Let me see. Danilo, anything you would like to ask, or shall we take?
Yeah, maybe a curiosity. Would you see an evolution of your work such that it would scale in the sense to reach diffusion at scale?
Yeah, so we should be able to try all that. We have basically in none of the approaches that we took, scalability was a thing that we considered. So we just wanted to make this particular thing work with BLE and Wi-Fi, and try to do some kind of a comparison and then present our results as a paper. But going by the interest in this particular thing, I think we should be able to work more on all this. Bring in more people with respect to hardware optimization and then ML aspects of it, and then try doing all these new stuff. We should be able to try.
Very good. Thank you. Thank you so much for your comments.
Yeah, I think so far we have answered all of the questions. I'm just scrolling through right now if I have missed any of the questions. But yeah, we had a lot of questions. This one, let me see.
Rosina, maybe if I may suggest also,
Sure.
you know, there will be Edge AI Asia event in the second half or at the end of this year in Taipei. So maybe you could also consider to submit demonstrations and bring a demonstration live to Taipei if you could. I mean, you know, interacting with the others, showing the prototype which is working live, that would be very helpful in terms of interactions and getting other comments, feedbacks from the people.
Sure. We would be more than happy and excited to present our work there. So by that time, I think we should be able to work on all the inputs that you guys gave here. Work more on the ML part and the hardware optimization and also the scalability. So by that time, we should be able to deploy this solution in one of the places here, and then collect more data and then keep improving the accuracy and performance. Yes, we should be able to do that.
Yeah, that's a great idea, actually. Vadiraja, I don't know, do you have somewhere your email address, maybe in one of your slides? Or maybe
Yeah, I'm putting that in the chat here. Is that okay? Comment?
Yes, you can put it in the chat, because I'm sure maybe people would like to reach out to you. And then
we'll also put it in the slide. Just a second.
Yeah, because if you have it on the slide, we can just bring the slide up.
Yeah, sure.
Your email, and then all of our viewers, the audience, can have a look at it. So,
yeah.
So that they know where and how they can reach you. Okay. Thank you, Vadiraja. I see you put it here already, so everyone can see your email and everyone can reach out. So thank you very much to you, Vadiraja, and also Bavitha and Prajwal. Really, thank you very much. Our audience, as far as I can see and what we have heard from all the questions, they really enjoyed your presentation. So thank you very much for joining us today. And we are looking forward to having you join us again when you, as Danilo said, to see the progress of the
project. Keep us up to date, especially if I may, from the on-device learning perspective and scalability. Really would like to get updates when you will have some. And thanks a lot to share your and your team knowledge with us today, because it was simply great. And we need example like yours of university that share research and inspire and help us to build a community.
Thank you. Thanks for the opportunity to AGI Foundation, Pete, Rosina, and Danilo. Thanks for being a great host. We would love to participate in more such events. And as part of PES University and Department of Computer Science and Engineering, and just to mention our director Prasad sir, We are open to host all these kind of events here. We have wonderful facility at PES University. We would love to host AGI event at PES University too in the future.
Oh yeah, thanks.
And have you all on our campus for more such events. Thank you. Thanks for the opportunity. Thanks for all the participants and thanks for all the wonderful questions. Thank you. And I also thank Bavitha and Prajwal for joining me today here. Yes, sir, Danilo, sir. We missed you.
Yeah, and also a great thanks to Rosina for having organized such a talk and made possible.
Yeah, thank you.
You're welcome. Everyone have a wonderful day, and we hope to see you again in our next session for AGI Talks.
Bye.
Thank you all. Thank you all. Thank you so much.
Bye. Bye.